All right, if you're still with me, I am so sorry for these recordings. They're terrible, I know. I apologize, but I'm getting better at them. I'm now trying this as a PDF, and so what we're going to do is hopefully it's a little bit better. Okay, and from time to time I might need to stop it for a second, okay? So let's go ahead and take a look at, number 17 on your review, okay? And you're going to algebraically find the requested information. So given f of x equals 2 cube root x plus 3 minus 4, the first thing that I'm going to notice is I have some parameter changes happening. One of them, add notes. Okay, one of them is that we have this shift down 4, okay, and then we have a shift of positive 3. That's going to go left 3. And then I also have a scale of 2, and I have a cube root function. So that's going to kind of look like something like this. All right. So before I start answering all of these questions, what I'm going to do first is actually go down to letter F, and it says sketch the graph of the function. Be sure to label your axes and show your scale. So because it's asking me to show my scale, what I'm going to do is I'm going to go ahead and kind of create some values here before I start sketching this out. Okay, so I have x and y, and because I'm working with a cubic, I want factors that will cube out. So like 1 outside of this radical. 8 is a good number. So if I add and I want 1, if I want 1, what is, if I add 3, what would that be? That would be negative 2. So looking at negative 2, and I substituted this into the formula, so that would be 2 cube root negative 2 plus 3 minus 4. Okay, so negative 2 plus 3 is going to be positive 1, okay, minus 4. So cube root of 1 is just 1, so that's 2 minus 4, which is just going to end up giving us negative 2. So that's negative 2. So on our graph, we're going to end up having negative 2, okay, and negative 2. So we're going to end up going by 1. Whoops, that should be negative 2. 1. Negative 1. All right. So the next point that I'm going to have, I really want to be the cube root of 8. So that's going to give me 5. If x is 5 plus 3, we're going to end up substituting that in. That's going to be 2 times the cube root, okay, of 5 plus 3 minus 4, which is just going to give us, that looks like a 9. 4. Okay, so that is just going to end up giving us the cube root of 8 minus 4, 2 on the outside. This simplifies just to 2. 2 times 2 minus 4 is just 4 minus 4. Okay, so that's going to end up being just 0. So it's going to be 5, 0. 1, 2, 3, 4, 5. It's right there on the x-axis. Okay. All right, now back to a little bit of information about this graph. We know that the parameter changes is they're going to shift 3 in the left, 1, 2, 3, and we're also going to go 4 down. Okay, so that's going to be the center or the turning point of our graph, and I know that this side kind of looks like a square root, so that's going to go out that way. This side is going to kind of reflect and rotate in order to show that cubic. So this is the center of the graph. All right, now the next step is we're going to go ahead and talk about the domain and state the domain and range. Now just viewing this graph, the domain and range is going to be all real numbers for both. So that's going to be domain is all real numbers. Range is also all real numbers. We need to look to see what the y-intercept is. If we're looking for the y-intercept, x is going to be 0. Okay. If I know that x is 0, I can substitute that back in. This would just be f of x equals 2 times the cube root of 0 plus 3 minus 4. So this is going to end up being the cube root of 3 minus 4 times 2. Okay, now if it's asking for a y-intercept, we're not going to be able to graph this, so you actually need to find the decimal answer for the cube root of 3 times 2 minus 4, which simplifies down to, whoop, hold on, I may have had the wrong work here. So we end up with negative 4. Okay, so that's the cube root of 3 minus 4, which is just going to end up being 0, negative 1.12. It's not wrong. I just didn't have it in front of me. Alright, because it's a y-intercept, you need to make sure it's written as an ordered pair. Now the x-intercept, that's when y equals 0, so we're going to substitute when this entire graph equals 0. So that's 2 cube root of x plus 3 minus 4. We're going to add that 4 to the other side, so that equals 4 cube root of x plus 3. Divide both sides by 2. Then we're going to end up with 2 equals the cube root of x plus 3. Now that I have a radical isolated, I can cube both sides. So 2 to the third is going to be 2 times 2 times 2, which is just going to be 4 times 2, which is 8. Okay, the cube root is gone, so that's just x plus 3. Subtract both sides by 3. I'm left with 5 equals x. Okay, now because it's an x-intercept, I can't just leave it that way, and I know that y is 0, so I'm going to end up with 5, 0. Alright. Now the next problem we have is D, and that's finding the value for which f of x equals 1. So if I know f of x equals 1, that just represents the fact that y equals 1. So I can substitute that value in, and the entire thing equals 1 times 2, or equals 2, cube root x plus 3 minus 4. So the first step is to go ahead and add that 4 to the other side. I'm left with 5 equals 2 cube root x plus 3. Divide both sides by 2, so that's just 2.5 equals the cube root of x plus 3. Oh my goodness, so I'm running out of space. So I'm going to cube both sides. And I should have used different colors. Okay. So then that's going to end up being 2.5 cubed, which, hold on. Alright, so that's just going to be 15.625, that 2.5 cubed. Okay, let me erase this part. Okay, equals x plus 3. Sorry, f of 4. Squeezing you out of your space there. Okay, now the next step is we're going to go ahead and subtract 3 to both sides, so then we're going to end up with 12.625. And as an ordered pair, or you can just rewrite it as, well, you can write it as an ordered pair, really. That would just be 12. It just asks for find the value. So your answer would just specifically be 12.625. Alright, now for E, we're going to find f of 4. F of 4 represents x. When that is our value, our variable, we're going to substitute that in to the equation for wherever x is, which is going to start off being 2 cube root 4 plus 3 minus 4. Okay, so we're going to substitute on the we're going to simplify on the inside. Okay, and I'm going to rewrite f of 4 here equals 7 plus 3 is just going to give us the third root of 7. Okay, minus 4, and the 2 is in front. So we're going to end up with the f of 4 equals 2 times the cube root (7). Okay, times 2 minus 4. Hold on. Okay, so that equaled f of 4 equals negative 0.71, I'm sorry, 174. All right, so that's going to be the solution. Now, let's go ahead and take a look at number 8. Now, looking at number 8, given that problem y equals x squared plus 3, solve for its inverse. When it says solve for the inverse, algebraically, we're going to go ahead and rewrite it. That's just going to end up being the first step is to switch x and y. Okay. And then the next step is we're going to determine the domain and range of the quadratic that it would have to be in order for the inverse of for it to be an inverse of the function. The graph is for your convenience if you choose to use it. Okay, so looking at this, we're going to go ahead and isolate y. First step was to switch x and y. Now we're going to go ahead and isolate it. Subtract 3 to both sides, so we end up with x minus 3 equals y squared. We're going to square root both sides. Okay, then we end up with the square root of x minus 3 equals y. And then to rewrite it as an inverse, that would just be f of x. The inverse of f of x equals the square root of x minus 3. All right. Initially, when we graph this quadratic, we're going to end up having the perimeter shifts tell us that it's going to shift up 3. Okay, so that's going to be our parent function. When it reflects over the x-axis, y equals x-axis right here, this equation, okay, we're going to end up having this reflect over here, and this side of the quadratic reflect over into the negative quadrant here. This positive, because when we solve for this, this would actually be plus or minus, but we only want the plus side of things because otherwise the other would give us a negative part of the radical, which would not allow it to be a function. So we need to restrict the domain because we do not want that side at all. Okay, so our first value that we do want to see with our domain restriction, okay, would be that the domain needs to be 0 less than or equal to x less than positive infinity. Okay. Now, the next one, sorry, not the next one. So when we graph this, this is going to end up being positive 3. Okay, and that is the part that we want to see. That is the solution. So it says the graph is here for you to use it if you need to, but it's asking specifically for solve for its inverse, which is this equation right here. Okay, and then determine the domain and range of the quadratic you would need in order for the inverse to be a function. Okay, now if you were needing to find the range as well, the range would be all real numbers because we want to view all real numbers. Okay, you could specifically state positive 3 to positive infinity. That is also a solution that you could have. But I didn't need to restrict the range for this to also reflect to be this answer here. Okay. Number 19. We're going to use the inverse relationships and quadratic regression to formulate a square root function to represent the data in the table below. Show all your work. So the first step, you're going to be able to use a scientific or a graphing calculator on this type of problem. Okay, the very first step that you're going to have here is, since this is use inverse relationships and quadratic regression to formulate a square root function. Okay, so this is our square root function data right here. Okay, so square root function. So we need to actually create data for the inverse of a square root, which the inverse of a square root would actually be a quadratic. So if I have the inverse of this data, this would end up being our x values are going to switch. So instead of 0, 3, this is now 3, 0. I'm just going to go ahead and rewrite all of those values. All right. At this point, you're going to go ahead and go into spreadsheets and lists in your graphing calculator, and you're going to go ahead and input this data. Okay. All right, now because we have a quadratic equation the data right here is quadratic, what we can do is go ahead and run a quadratic regression. So go ahead and put this in your tables. Make sure you have the first column labeled X, second column labeled Y, okay, and go ahead and run that quadratic regression. Okay, that's going to give us our inverse function, because this is the inverse function of x squared minus 6x plus 9. Okay, so it's going to tell you A, B, and C as 1, -6, and 9, and you're going to substitute it back into your standard form of the quadratic equation. Now, this is your, this is a perfect square trinomial, so what we're going to do is when we factor it, okay, we need two factors that add up to give us -6 that multiply to give us 9. In this case, it's going to end up being x minus 3. Still the inverse function of x. So we're going to end up with x minus 3 squared. We're not done yet, because remember, this is our inverse and we need to go back to our original function, which is going to end up being just the square root function. So the first step here is we're going to go ahead and switch x and y. We're going to take the inverse algebraically. Next step, square root both sides. And then we're going to add 3. So now we're going to be left with y equals the square root of x plus 3. And there's your answer. Okay, I think this last one we can go ahead and take care of, and I'm going to put it on this video. Okay. Number 20, you can go ahead and skip, but basically when you're using a composition of functions, I'm going to go ahead and show you what that truly means. Okay, and a composition of functions just means that you're going to end up having f of x, try that again. Okay, we're going to substitute one in for another. All right, so what happens is, okay, and if this was f of x and this was g of x, we would end up with f of g of x, okay, which is just going to end up being f of g of x substituted inside, and then we'd also end up with g of f of x, which means that we're going to have one equation inside of the other. Okay, so in this case we start off with f of x, which is x squared, but wherever you see x, you now have the square root of x. Okay, and this is g, so g of x starts off with the square root, and then on the inside we end up with x squared. Okay, and we want that multiplicative identity, so the square root of x, squared is just going to end up being x, and the square root of x squared, or the square root of x squared, is just x. So those both are the same, and that shows that they are inverses of each other, which is something we did in Unit 1 or 2. Okay, so let's go ahead and take a look at this next one. So use the situation below to find the requested information for 21 through 24. Okay, so for this problem, we did a warm-up problem like this yesterday. The accident investigators used the relationship s equals the square root of 21d to determine the approximate speed of the car, s miles per hour from the skid mark, of the length d feet that the car leaves during an emergency stop. This formula assumes the dry road conditions and average tire wear. Okay, so a police officer investigation of the accident finds the skid marks 115 feet long. Approximately how fast was the car going when the driver applied the brakes? So we're looking for how fast. That's going to give us that we need speed, and we know the distance. So we're going to substitute that back into our formula. We are looking for speed. We already know that it's going to be the square root of 21 times the distance, which is 115. Now the next thing that we're going to do is multiply that out and take the square root of that. Our speed is going to end up being 49.1426. Now we wouldn't leave it like that, okay, but we would say about 50 miles an hour. Whoops, I'm just going to abbreviate that. Miles per hour. Okay, so let's go ahead and take a look at number 22. If a car is traveling at 60 miles an hour and the driver applies brakes in an emergency situation, how much distance does your equation model say is required for the car to come to a complete stop? So if I have speed and it's asking for distance, let's go ahead and substitute that in. So we start off with our speed being 60 miles an hour equals the square root of 21 times our distance, which we don't know. So that's actually going to be distance labeled as d. Okay, we need to solve for d. We're going to square both sides. We're left with 60 squared, which is 360 equals 21 times d. Divide both sides by 21. So we're left with 360 divided by 21, which is 17.142. Okay. Whoops, hold on. I didn't have 60 squared correct. That should actually be 3,600, which changes things. I'm left with 100. Oh, just by the decimal. Okay, 171 feet, 0.43. Okay, and that would be feet. Okay, and then what's the realistic domain and range for this situation? So when I'm thinking domain, okay, that's actually talking about the speed of the car. Okay, so our domain is the speed. Hold on one second. Alright, so we have the domain is the speed, okay, and the range is the distance of the skid mark. Okay, now if we're looking for speed, we're going to start off thinking about how fast do you have to go to create a skid mark. Okay, that's where I would start, but logically, our speed could start at 0. I mean, 0, because the car could be stopped in a way, okay? But that also means that we're not going to create a distance of a skid mark at all. Now, when we do have the distance of the skid mark, that could be 0 as well, because it could be that the car was fully stopped. Okay, now, for the distance, or not the distance, for the domain, which is our speed, we need to think about how fast this car would travel, because we wouldn't say 5,000, because that's just not a realistic number on Earth. Okay, so our realistic number, let's say you were going 100 on the highway. Now, you could have been going 120, and your distance would be a bit longer. Okay, now you're going to have to substitute that back into our formula, and you're going to have 221 times 100, and take the square root of that, and that's going to give you your distance. So whatever your reasonable range is, or reasonable domain is, it's going to affect your range and what that is reasonable as well. So for this one, it would be, if I had 100, that would be 476.19, just because that's a reasonable number. Okay. Okay, so let's go ahead and take a look at number 24. Does doubling the length of the skid mark double the speed the driver was going? Justify your response using specific mathematical examples. Okay, now the answer to this is no. The reason why is this equation is not linear, okay? All right, now it says to use mathematical examples. So my mathematical example is if I know that it's 100 miles per hour, okay, I would skid 476.19 feet. So therefore, if I was going 50 miles per hour, I should be skidding half of that. So it should be 238.09, which is going to in turn just be 10 feet. This is what it should be. But if I actually substitute that into the formula, and that's going to end up just being the distance, okay, or I'm sorry, the speed equals the square root of 21 times the distance. Pause for a second, I apologize. Okay, so this actually is the speed. The speed should have been equal, not multiplied up here. I made a mistake. Okay, so we're going to end up having 100. I'm going to pause. Sorry about that. Okay, so because this is speed, this is going to end up being 100 equals the square root of 21 times our distance. Okay, in this case, we need to go ahead and square both sides. That's 1,000 equals 21 times distance. Okay, and then divide both sides by 21. So we're going to end up with 1,000 divided by 21, okay, which is going to end up just being 47.619. I'm going to confirm that answer. I thought I was missing a 0. That's actually going to be 10,000 here for our numerator divided by 21. Okay, so 10,000 would create, okay, 476.19 as our distance for how far you would travel if you were going 100 miles per hour. Okay, so down here, if I knew that the speed was 50, okay, I could substitute that in. That would be 50 equals the square root of 21 times the distance. Okay, this is going to be 50 squared. 50 squared is, okay, 2,500 equals 21 times the distance, because this is going to simplify out. Then we need to divide both sides by 21. So then we're going to be left with 119.05 as our distance. Okay, so you can clearly see that this is not the same answer, so it is not linear. Okay, because it does follow that exponential, I'm sorry, not exponential, that square root function. Now we need to find the values of x that satisfies. Okay, a diver dives off of a cliff that is 60 meters high. His coach waits on a ridge that is 35 meters above the water to take the diver's picture. So in this one, it's best if you draw a little picture. Okay, so if you know that the diver dives off a cliff, so here's our cliff. Okay, it's 60 meters high. The coach waits on a ridge that is 35 meters above the water. So he's about halfway. So we have 60 that goes this way, and then we have 35. Okay. How much time has elapsed when the diver is at the same level, okay, height above the water, as the coach? Hint, h, so this is our formula, where this is our initial height in meters, and t is the number of seconds that have elapsed. So what we're going to end up doing, okay, is we're going to go ahead and write this formula down, equals negative 4.9 t squared plus h of 0. Okay, so substitute our values in is all that we're asked to find right now. So we want to find the height when he is level, so he's right here, he's going to jump. When he jumps, we want to know when he is right here at 35. Okay, that's the height that we want to capture. So we were going to end up substituting everything in. We need to find the time plus, okay, what's his initial height? It's 60, or his original height. All right, let's go ahead and subtract 60 to both sides. So we're going to end up with 30 minus 60, which is just going to give us our negative 25 equals, no, subtract 60 from both sides. We would end up with negative 25 on this side minus, okay. Now what we're going to do is divide negative 0.49. So we're going to end up with negative 25 divided by negative 4.9, and that's going to end up being 5.102 equals t squared. We have to square root both sides, so square root that answer. It's going to take all of 2.26 seconds in order for the instructor to time his jump just right. Okay. So that's seconds. So give a reasonable domain and range for the diver's dive. So domain on this one, okay, would be time. Whoops, I don't know why I did that backwards. And our range, we're going to be talking about the height of the diver himself. Okay, well the height, this is the easiest one to do, because the height we're going to talk about is the highest that he's going to dive is 60 meters. Okay. You can kind of talk about it being 60.5 because he might jump up and then jump down. I understand that, okay? But I'm going to say 60. And then if I was looking for how when he jumps into the water, because this is 0, he could go down a little bit and then come back up. So he could go down to -5. Well, -2 meters, because you have to think about how long is a meter. And it's pretty long because 1 meter is about 3 point something. So if 2 of those, that would be about -6 feet. And that's about how far you would dive underwater and then come back up. Okay, so if we know the height first, we can solve for the time. Okay, so at the initial amount, it doesn't have to follow this. So at the initial amount, he's actually 60 feet above the coach. Okay, but if we wait to see where he is at -2, the entire dive is going to take about 3.5 seconds. Or I'm sorry, 3.5 seconds. Okay. All right. That concludes the review, and if you have any other questions, please let me know. I may be in prior to the test itself on Friday morning, you can ask questions then. I also have tutoring on Thursday afternoons. Thank you. Bye.